everyone, my name is Lucila and I will be presenting alongside Elorey Brown and James Barrow. We chose two topics, and out of those two topics we chose three subtopics in which to present on. Firstly, we have marginal analysis with business and economics. Secondly, intermediate forms, and thirdly, infinite integrals. Marginal analysis in business and economics. I will be presenting on that. Most of us want to get the most value out of our resources. And the same goes for entrepreneurs and companies. We all want to make sure the benefit of certain activities outweigh the costs in order to be profitable. One tool for outweighing this relationship is marginal analysis. First off, we have a company manufactures and sells X hats per week. If the weekly cost and revenue equations are, and these are the equations for cost and revenue, or Rx and Cx. A. Find the profit function. To solve for the profit function, all we need to do is subtract C of x from R of x. So basically here, we subtract 30x from 100x, and our answer is right here. 70x minus x squared divided by 10 minus 40,000. Okay. For B, using differentials, if production is increased from 1,000 to 1,100 hats, find the appropriate change in revenue. Okay, so dr equals r prime of x times dx. dx is simply the change in production for this problem. Okay. Now we have to find r prime of x, which is equal to 100x minus x squared divided by 10, and then 100 minus 2x divided by 10, and then the final answer is 100 minus x divided by 5. So the dr here, it would be $80,000. For C, the question is find the average cost function. Okay, when we are looking for the C average, we know that all we need to do is put it over x. So that's what we did here. Okay. And D, find the marginal cost function. For marginal cost function, all we are looking for is the derivative of the function. And we know that the only one we can find a derivative for is 30x right here. So the final answer here is 30. E. Find the total cost and marginal cost in a production level of 200 hats per week. Okay, so since we are producing 200 hats per week, we introduced 200 here where C of x was, so now it will be C of 200, and then our answer will be 46,000. Okay, and C prime will remain the same. F. Interpret part E and use it to find the cost of 201 hats. Okay. At a production level of 200 hats per week, the total production cost of 46,000 is increasing at $30 per hat. So if we know that the cost to produce one hat is $30. So if you increase it by 1, the answer will now be 46,030. Conclusion. So before this class, I did not realize how easy it was to find out how much it would cost me to produce one more plate of ceviche for my business. My sister and I sell ceviches on weekends, and these are very important things that I am learning how to do, and I am glad I am learning how to do them. Up next, we will have Elorey and Jane presenting.
Hello, my name is James Barr. I'll be presenting on Chapter 6, which is integration and the subtopic of indefinite integrals. The integral can be used to calculate areas, volume, and the index of income concentration and consumer surplus. There's a number of methods of calculations, among which are functions, derivation, and integration. Indefinite integral is a function that takes the antiderivative of another function. It is visually represented as an integral symbol, a function, and then a dx at the end. Indefinite integral is an easier way to symbolize taking the antiderivative. The integral is also called as antiderivative as its reverse process of differentiation. It is also defined as an integral whose upper and lower limits are not defined. For example, a way to interpret then the integral equation would be the integral of f of x with respect x as equal to capital Fx plus c. If you differentiate f prime of x will get you f of x. Now there are some examples of applications of integral which can be applied in various fields like mathematics, science, and engineering, and it can also be used to calculate the mass and momentum of a moving vehicle, for example. Now I shall provide some examples of integrals and then go by them step by step. Integral of 3x to the 5th power dx equals 3x to the 6th power. You get the 6 by adding 1 to the 5, which is the exponent, and then you divide it by 6, which is the same, plus c. And then you simplify it more, equals 1x to the 6th power over 2 plus c. Next one is the integral of 3 square root of x dx equals integral 3 1 over 2 dx. Simplify it again, equals 3x 3 over 2 over 3 over 2 plus c. Next is integral, open brackets, 3x to the 2nd power minus 2x plus 1 close brackets dx equals 3 times x to the 3rd power over 3 minus 2 times x to the 2nd power over 2 plus x plus c equals x to the 3rd power minus x to the 2nd power plus x plus c. And finally, the integral of 3 e to the x power dx equals 3 times e to the x power plus c equals 3 e to the x power plus c. And that's it. And thank you.
I am Elorey Brown. I am presenting on Chapter 3, the limits and the derivative. Objective, explanation of the topic, subtopic, impact on analysis as well as interpretation of data. How the topic aid in decision making, how the topic can be applied to real life problems. The limits and the derivative. In calculus, the limit is the value of a function that approaches the input, approaches some value. Limits are essential to calculus, and the mathematical analysis are used to define continuity, derivative, and integral. The derivative of a function are some point characterized as the rate of change of the function at this point. Derivative means to derive, to obtain from a function. Comprised of the backbone and the sense that derivative of other functions can be derived from them using the basic differential rules. My subtopic is the indeterminate form. The indeterminate form is used because the limit of an indeterminate form may or may not exist. The expression does not represent a real number and should never be used as the value of a limit. If the limit is an indeterminate form, further investigation is always required to determine whether the limit exists to find the value if it does exist. Here you can see a real-life situation where it is given, let function of x where 2x squared minus 3x minus 2 divided by x squared plus x minus 6. Note there are key factors where you have to apply the rule. It is given that it says find a, where the limit of a function of x approaches 2. You could see step by step where I did the analysis of implementing where x is, you substituted for 2. Further, you go down to find the answer where we got 0 divided by 0, which means in the indeterminate form, which means it does not exist. As we go back to the key factor where we could see we have to implement it. The rule further states that we have to investigate further to analyze whether the limit exists or not. So we further factorize a, which is the numerator, and then we further got 2x plus 1. We further factorize the denominator, and then we got 3x plus x plus 3, sorry. Then we took where a says that you find f function where the x approaches 2. We then implemented where we factorized the numerator 2x plus 1 and the denominator. After factorizing, we got x plus 3, and we further analyzed to get the answer where it is 5 divided by 5 and the answer is 1, which simply means that yes, the limit does exist. How does the topic aid in decision making? The main objective of decision making information help decision makers in providing accurate time-based calculation. Information also helps students make the right decision in turbulent environment. Information in decision making helps solving both structured and unstructured problems in environment. How can it be applicable to real-life situation? The study of calculus is the concept of limit. This concept helped us to describe a precise way the behavior of a function x where x is closer but does not equal to a particular value. Today, calculus is used not only in the physical science but also in business, economics, life science, social science, and any that seeks to understand the dynamic phenomena. Take every opportunity to practice as well as apply the critical thinking into all aspects of life where applicable. My conclusion is this chapter was very interesting, and personally for me, I needed to go over this presentation, this specific topic, because for test 3 the grade wasn't too simple, pretty good. But however, after doing this presentation, I was able to grasp the concept clearly. However, I've learned that calculus information are interested in how the values change from one aspect and affect another. Today, calculus is not used only in physical science, but social science, like I already mentioned, economics, life, social science, any discipline that seeks to understand the phenomena of the environment.